Hello, this is Cara. This is my reassessment for Newton's second law standard that we took last week. I got a 2 out of 5, so I definitely need to prove that I can do this. I misread the question. I guess I got a little excited in class and I solved for force when you asked for acceleration. And the calculations were correct, but my free body diagram was totally wrong. So this problem that I'm working on is my reassessment. I'll read it. A 1 kilogram mass hangs by 1.8 meter string from the top of a train car. The car accelerates to the left such that the mass swings back 30 degrees. What is the magnitude of the tension in the string and what is the acceleration in the mass? Okay, so first, just in my drawing of the train car, I have the mass connected by a string hanging off the back, 1.8 meter string, and 1 kilogram mass, and it's being pulled back 30 degrees because the train car is accelerating to the left. So this is the free body diagram, and I wanted to be clear that the only forces on this mass are the string that it's attached to the car with, so the forces in the direction of the string being attached to the car, and then the long-range force is gravitational force. And acceleration is not a force, it's just something I included in my free body diagram for the standard. So, okay. Next, I want to write out the forces that are acting on the net forces that are acting on the mass. In F direction, I have T sine 30, which is coming from this X portion of the tension force, T. And then that is also equal to MA in the X direction because the forces, or the train is moving to the left in the X direction. The net forces in the Y direction, I have T cosine 30 minus mg. T cosine 30 comes from this portion of the tension force, and then mg is completely in the Y direction. I also wanted to reorder this F net in respect to the acceleration. So I've divided both sides by mass, and I come out with AX equals T sine 30 over mass. And then I want to take the F net and solve for tension, because tension is one of the requirements of the problem is the tension of the mass hanging from the string, or the tension of the string, I guess. So I took T cosine minus mg, subtracted mg from both sides, and then divided that by the cosine of 30, and that gives me tension. Next, I'm going to just substitute in mg over cosine 30 into my AX equation, which gives AX equals mg sine 30 over cosine 30 times m. Mass cancels out, and sine over cosine is tangent, which leaves us with AX equals g tangent 30. Now I want to solve for tension and acceleration. Just plug in my values from the original equation. So I have a 1 kilogram mass times g, 9.8, divided by the cosine of 30, which my calculator tells me is 11.32 newtons because it's a force, equals tension. Acceleration, so AX equals g tan 30. I type in my calculator g, 9.8, times the tangent of 30 was 5.66 meters over seconds squared, the acceleration. Okay. Thanks for listening.